Hey there, welcome to the ETHGlobal Buenos Aires workshop for Self Protocol. I'm Evie, I'm a smart contract engineer with Self, and today we're just going to be taking a little look at what Self Protocol actually is. We're going to look at the bounties that we have on offer for the hackathon, and we're also going to go through a code example of our workshop repo, which has a minimal implementation showing you how you can integrate Self into your own project. So, firstly, what is Self? Well, Self is a zero-knowledge protocol that allows users to prove they have a passport, an ID card, create a zero-knowledge proof of that, and that allows them to selectively prove information that the document contains without ever having to reveal the document itself. And so traditionally we see with KYC providers, which are checking users a real person and checking all these sorts of information, the issue here is that essentially users are relying on trusting these third parties to securely store their data. And you upload your passport, your ID card, which contains quite sensitive information, and yet these KYC providers do not do a great job of securing that information, and we've seen countless database leaks compromising users' privacy, which is really not great, obviously. So, what can we do? Introducing Self. So with Self, instead of storing your data on a database, you instead create a zero-knowledge proof, which transforms this data into something that can be used to prove information without ever having to show the document itself. And so what we do is we leverage passports, for example. And why we do this is because they're quite difficult to obtain. You need to go through this government verification process, which proves that you're a unique person. There's only one passport per person, and it also has a NFC chip on it, which allows devices such as a smartphone to extract secure information from them. So this enables a few different use cases. The first one being obviously Sybil resistance, because your passport is a unique document that only you could have, and you can only have one of them, and so it can be a way to add Sybil resistance to your protocol. Next is that you can obviously reveal facts about yourself with your ZK proof that you generate. And so anything that's on the document can be used to, you can prove information about that. So that includes stuff like your name, your date of birth, your issuing state, your nationality, your gender. And then finally, you can do things like proving facts about yourself, like making sure that you're above a certain age, like over the age of 18, or that you're not from a set of countries, or that you're not on the OFAC list, which is the list of addresses that the US government has sanctioned. And so if you're interested in compliancy, this is obviously really useful as well. And so recently, Self has started integrating non-biometric data sources like Aadhaar, and that relies on scanning a QR code in like a PDF and doing the proper certification. And so we can actually see with the coverage map we had 1.1 billion potential reachable users with biometric passport holders, 200 million with biometric ID cards, and now an extra 1.4 billion with Aadhaar cards. That reaches us a total amount of users that could potentially be reached of 2.7 billion, and we're obviously looking to make this map greener by the day. So yeah, what does the experience look like, and how does it all work really? So firstly, you download the Self app, and then you scan your passport. It reads the MRZ, which is the two bottom rows of data on your passport. And essentially, this is a way of allowing you to access the chip and authenticate yourself. And so once you have scanned your document and scan the chip, hashes the data along with a secret. And this is stored on chain. And we can then later use that to be proving information about a document. And so when you prove information about yourself without revealing the actual document itself, that's called a disclosure proof. So the app creates a QR code which contains a request for certain information. Users then scan the QR code, which opens the Self app, and they're prompted like they would about what they would like to do with disclosure proof. They're going to see what information is going to be disclosed, and then if they accept it, proof is verified. And if successful, information is passed on to the app or the smart contract for utilization with their custom logic. So just on a high-level architecture for the registration process, obviously we have the the passport being scanned by the mobile app, and you get a secret generated, and you can either store that on a cloud backup or like locally. This is passed on to the TEE. This is an encrypted format because it's a hash of your secret and all your passport data. And so this is never accessible to anyone. And we also verify that the TEE is actually the correct environment so that it's doing what we want it to do. And then once that proof is created, it's submitted to the on-chain registry. Make sure that's actually a legit proof, of course. And then for the actual disclosure proof, your app generates a QR code or a deep link. And you, with your mobile app, you open that app, and that opens up your self app. And then the ZK proof is sent to the backend. And you can either use like an on-chain verifier, in which case it's going to go to your smart contract, or you can use a backend verifier, in which case it's going to go to your API endpoint. And you can see we have the two different the repos there for on-chain or off-chain, self XYZ contracts SDK or the self XYZ core SDK. So we have a few bounties. So firstly, we have two categories. We have the on-chain verification, and so we have 3 winners for that. That's only 5,000, 2,500, or 1,500. And then we have the off-chain verification track, which is a prize of 1,000. So there'll be 4 winners in total. And yeah, we're really excited to see what you come up with. And so we're going to be using the workshop repo for our code demo. That's github/self-xyz/workshop. And you can see the 2 different pathways we have here, right? So either way, your app is going to be running. You're going to have a front end generating a QR code, and then that's going to go to the user. They're going to scan it, right? And then the ZK proof that is generated is then going to be sent either to a backend verifier if you're doing off-chain verification, or to your smart contract if you're doing on-chain verification. Okay, so let's get into the code example. So I've already downloaded and cloned the workshop repo from my GitHub. And so I'm going to start with the front end stuff first. So we have here the front end component, which is the QR code. And we go to pay TSX. We can see we construct the QR code here in the self app builder component. And that contains information that's going to be passed on to the user's self app. That contains stuff like the version number, the app name, the scope, the endpoint, which is your smart contract. If you're using the on-chain verification, using off-chain verification, it's your HTTPS API endpoint, and your logo, the user ID, which can be either like a hex, which here for Ethereum address, or you can use a UUID, the endpoint type if it's going to be on mainnet or testnet. We can also have user-defined data. And so, for example, you could define different types of configs to verify people based on this input. You can also just have users enter whatever information you want on the front end, and this can be passed on to the when you get the return call. So then we also have the disclosures, and so this is what you're going to be asking the user to prove. So this for the demo example, we just have the minimum age check and the excluded countries check. We're making sure that the user is over the age of 18 and they're not from the United States here. You can see. And so then essentially, yeah, this is in the QR code wrapper. It's built up. And then they have like, your hook here, obviously, after you have a successful verification. And then, so on the smart contract side, we go to proof of human. And so proof of human is it's a relatively simple implementation. You can see if your smart contracts, you inherit from self-verification root. And so we have 3 parameters in a constructor. So firstly, we have the identity verification hub. And so this is the on-chain address that is used to verify the user's generated ZK proofs. And so that'll change depending on if you're Celo mainnet or Celo testnet. You can grab the which address is which from our documents. It's also available in our ENV example. The next parameter is the scope. And so this is essentially like a unique identifier for your application. So attackers would otherwise be able to do a bit of like traffic analysis, and they'd be able to identify or be used to identify users who could do multiple disclosures across different apps. And so having different scopes essentially hides with the protocol and makes you less vulnerable to these kind of attacks. And so you just need to make sure this value is the same in the self app builder component. And so if we go back to here, you just want to make sure the scope that you're passing in, which is self workshop, is the same that you're setting up for your smart contract. In general, and also for the verification config, in general, you really need the smart contract to line up with the front end. Yeah, otherwise you'll run into errors. And yeah, so we have the verification config, and that's just a way of enforcing your config on chain. So on the front end, we have it configured to check the users over 18 and they're not in the USA. And so then we'll create a verification config that also matches that. And so obviously you're inheriting from self-verification root. So there's two functions you need to implement. First one is the custom verification hook. And so after your proof has been verified correctly, then you can actually work with the data that's been proven, right? Firstly, we have user data. And that was the user-defined data from the front end. That was this part. So that's we hit here. Hello. And then the other component is the output, right? And so that is using the struct. You can see all the possible data you can potentially get from the user. Although if you don't ask for it in the disclosure, yeah, then you're not going to be, it's going to be an empty, So for our example, the only data sources we'll have access to are minimum age and excluded countries. But just say, for example, I wanted to grab the issuing state, I could do something like last issuing state equals, output issuing state. And yeah. So then you also have the get config ID function that you also need to implement. And so this is passed into the hub contract. Here we go to get config ID. Yeah, so in the verify self proof function, which is the main function that is verifying the proof, this config ID gets passed into the call on the hub verification. And so what you can actually do is you can use this, you can see one of the inputs is user-defined data. We also have user identifier, and these can be used to make sure you implement custom verification. So for example, if user-defined data, there was an option saying, hey, I'm over the age of 30. You can pass in the user said over 30. So this would be like, 30, right, whatever. And, and then you'll check, you have a stored set of configs, and then that'll be passed into the hub. And so you'll check over the age of 30, or otherwise you'll use your default implementation. And just but for the demo example, I'm just going to keep it very simple, and we're just going to have a default verification config that we define in the constructor, right? Yeah. Okay, so I've already deployed a smart contract. So you can see here, I just ran that with the, I went to cd contracts, and then I ran the deployment script, deploy proof of human, which runs the deploy proof of human script. And we can see it's, yeah, you just got to make sure everything lines up with the front end and the back end, right? So you can see we pass in the hub address and the scope seed, and that's from ENV. And so you can see we're on Celo Sepalia because we're using a mock passport, and it's just for testnet. But if you had mainnet, you would want to use this address. Make sure your scope seed matches your front ends one, self workshop, right? And then self workshop, great. And make sure you're on the right network as well. And of course, don't forget to put your deployer's private keys in ENV as well. And so it grabs it from the ENVs for the hub address, the scope seed, and then it's also using this self-utils function to format the verification config properly, and then it deploys a contract. So once you deploy the contract, you grab your contract address and you go to your front end, and you can see in the example, this is the endpoint. And so for us, we're doing on-chain verification right now. So we put in a smart contract here. But if you were doing off-chain verification, you put your HTTPS endpoint. If you're doing local, just make sure to use ngrok. And also make sure the contract address is in lowercase. Okay, so now we're going to spin up the front end. So we're going to go to app. I'm going to run it. Okay. All right, so now I've got a website. I've got my QR code, and I'm going to scan it with my phone. Open up the Self app, if you can see that. And so it's asking to authenticate who I am. And then it's also going to be asking to make sure that I'm over the age of 18 and that I'm not a citizen of the USA. I can also see the additional information. Hello, ETH Buenos Aires. So I hold to verify. And it's now approving. Take a few seconds. And boom, we can see identity verified. The front end has, well, we've got a nice little skeleton dancing around there, but you can put whatever you want, obviously. And on the Self app, it tells the user that they successfully passed the verification. So, yeah, and then also obviously, this is also calling this custom verification hook. So on the deployed contract, you would have all these data points now set, right? But you can do whatever you want with the output and the logic. Okay. And so the other thing to talk about here is the off-chain verification. So we can take a little look. So you go to this part, backend integration. Nice little like documents for this, and so you can see it's essentially it's the same kind of data is being passed around. It's just processed a little differently, verified off-chain with the backend instead of on-chain with the smart contracts. But you see, passing the scope, passing the endpoint, you're determining if it's going to be mock passports or false. Allowed IDs, and so that's just the like ID type. So that's like, do you want passports? Do you want passports ID cards? Do you want passport ID cards Aadhaar? And you have config storage, and that's kind of similar to the config ID. Talking about having different kinds of config stored to have different types of verifications applied to the user data. That's what you would store there. And then the user identifier type. If that's going to be like a user address or hex or the UUID. And then for a example of how to integrate that, go to start, bottom up. Yeah, so you just install it. That's the self XYZ bar. And then you can see a working implementation here. So you can see the in this example, the check is here, default config storage. So they're checking the minimum age is 18. They're checking that they're not from Iran, Pakistan, Iran, North Korea, Russia, or Syria. And we're also checking that they are not on the OFAC list. And then you can see, basically the data is extracted, the proof is verified, and if it's successful, then you can enact your own custom logic. And so yeah, it's kind of up to you to figure out if you want to use off-chain verification or on-chain verification. Both different pathways depending on your app and your project and what you want to do. So I think that wraps it up. I just want to say thank you so much for listening, and we're really excited to see what you can build with Self and with the magic of ZK proofs, because it really is magical. This ability to prove information without ever having to reveal the information. It's really cool, and yeah, good luck.